We just got done talking about virtual environments, so we'll end up using that indirectly, but our main focus is not going to be on virtual environments, it's on SQL. And the question is, so now we know how the basics of SQL works. We can create tables, we can insert data into those tables, and then we can run queries to extract information from those tables. So there's three basic things that we can do with SQL, and those are the three basic things that you need to be able to do. So create tables, populate those tables, and then run queries on those tables. So we can do all that with SQL, but there's a problem or a question that may not be apparent at this point, which is how do you use this in a web application, right? So this is a web application or a web development bootcamp. So our focus is on getting something usable. So if we think about the whole system, a user enters something on a form on a website, and then that information gets sent back to a server somewhere, and eventually something's going to have to get turned into a SQL query, either in an insert statement or a query. So how does that happen? How do you go from a string somewhere, someone submits a form on the internet, to an actual database query? And then once you make the query, how do you do something with that information? So fortunately, this very complicated problem has been solved by some smart people. And like many things in Python and JavaScript and other languages, there are common problems that have been solved in a way that solved better than you could do yourself. So one of these solutions for how do we connect SQL to another programming language that we're using for web development is psycopg. We'll take a look at that in a sec, but yeah, so here we are at the README, and we're basically going to be learning about how we can use Python code as a wrapper around SQL. So far at this level, this is we're still pretty low level. So we're actually just going to be writing normal SQL queries. We're just going to be passing in those SQL queries essentially as strings, as parameters to this Python module, which is going to convert that into actual queries. So this may seem like it's not really that different from what we were doing in some kind of in some ways. So you're still going to have to write full SQL queries, insert statements, creating tables. Everything else is going to be the full query. So you're still going to need to know SQL in order to use this driver, this Postgres SQL driver. But we're starting to get more into the how this will actually be used in an application. Okay, so it says pip install psycopg2, and of course we can do that. Couple problems though. I would suggest, since we've just seen the video on virtual environments, that we're not just installing things into our global environments, and so we'll end up creating a virtual environment to install this. But before we do that, let's take a look at the documentation. It's always a good idea to get at least vaguely familiar. If you decide to use a given library, some of the things you might want to check for before you decide to use it is, is it credible? Is it used by other people? Are there lots of problems? Is it being updated regularly? Is the documentation good, for example? So we can go ahead and look at the documentation. So we'll be using this one, but it looks like they're developing a third. So that's always a good sign. So it's something that's going to continue to be improved. So let's look at the documentation. And there's a lot going on. So we're not going to worry about installation right now. But basic module usage can go here. It looks like we have a little mini example tutorial that'll get us up and running. So I'm confident now. I'm pretty confident that once I get this installed, I should be able to use it, at least up and running with the basics fairly easily. Okay, so let's go ahead and go here. And so before we just willy-nilly install stuff on our computer, let's create a virtual environment. So we do that with Python -m, and we'll use the venv module, and we'll create a virtual environment, and we'll call it, so oftentimes, the kind of lazy way to do it is venv, but I want to make sure that we know that, what's what here. So Python is what we're calling. We're using the -m flag. This is the virtual environment module, and then this next term is the folder that we're going to use to label our virtual environment. So again, I'll just call it SQL venv just for fun. And my SQL environment is created. All right. So now that it's created, I'm going to activate it. And to activate it, source SQ, we'll call the invert, and then activate. So we'll run this. Now it looks like I'm in here. My virtual environment is activated. So now I'm isolated from the rest of my machine. So I can go ahead and start installing Pip modules. So we can go back and take a look here. So most of the time, pip install, like the name of the thing is what you install. Not all the time, but usually that's it. So we'll just do pip install psycopg2. And that should take a second. It's going to go ahead and run. And it should install. Okay, I know it's a little, screen space is a little tight here, but so I don't have to keep going back and forth. Let's see if this works. All right, we'll see how this goes. So we've now got our virtual environment. Looks like things are good. We've installed it. We haven't checked it, but we'll do that in a sec. So let's create something called, we'll create a folder, and then we can start running things. So import psycopg2, and then it looks like we can connect to an existing database. I don't really understand what this is yet, but maybe it's okay to copy paste. We'll just copy paste all this. Let's see what happens. This is the little mini tutorial example that the people who made this supplied. So I'm gonna hope that this works without too much trouble. And okay, looks like so it looks like what we're doing here, I mean, we can actually read the SQL here. So we're creating a table, and then we're inserting some data into a table, and then we're going to run a query on the table. So that pattern should look pretty familiar. And then there's something called committing. And then it looks like we close the cursor and then close the connection. Again, I'm not quite sure what all that means, but that's okay. So if we try running this, we get an error. So we just copied and pasted this tutorial, and now I'm a little bit annoyed now because I'm trying to use this thing, and now I have another headache, yet another problem that I have to solve. So let's read this error. Role Postgres does not exist. So we haven't talked a lot about permissions and roles and things like that. Kind of just creating databases and then doing stuff with them. But the reality is that you're going to want to, there are super users and regular users, and you can give people different levels of permission. Right now, we've kind of been doing everything with our database as the super user, which is Not great, but we're gonna keep doing that for a little bit. But just so you know that in the professional context, you'll be not just having one user. So what Postgres is actually looking for is the default user will be the name on your system here. So we can go ahead and let's do. So your name will be a little different, but whatever your username on your system is. Let's try running this. Relation test already exists. Okay, so looks like I already have a test database. So let's try that one more time. Okay, so I'm running into all these problems. Now I'm pretty annoyed, but at least we're getting different errors, right? So at first, the issue was that our Postgres didn't exist. So I changed that. Let's say I looked up some stuff and I decided to play around with some stuff. So now this is the misspelled username of my computer here. And then I tried running it, and then it said that the duplicate table, so relation tests already exists, and that's when it tried to create this table. So if I then go ahead and delete, right? So I'm trying to create this table test, but this table already exists. So then I go ahead and delete it, and then when I try to run it again, it says that the database test does not exist. So this is all just kind of a big confusing mess, but one solution here is to just go ahead and create. So there are a couple issues that we're gonna tackle in a second, but for now, I think what we can do is we'll create a database called test or whatever we're using here. We're just sticking with the default for now, and then let's try running again and see if we can fix this for now. So the most recent error is the problem is that it doesn't exist, so let's try creating it. Okay, so now I've created it. So I have a test database. I can, let's say PSQL. Okay, so that works. Cool, so I do have a database called test. So now if I run my test file, no problems. Okay, so that's good. I don't really see anything, but I don't get an error. So, I had to go through a few different steps, and this tutorial didn't quite work out of the box. I had to play around with stuff, so it's a pain. Unfortunately, this is often how these things work. So now I've got this tutorial, this little example working. It might be worth exploring a little bit what all these things actually do. So you can expand this for now. So we have, if we look here, we can kind of block this off based on what we know about SQL. We have helpful comments, right? Execute command, this creates a table. Okay, so first we connect to an existing database. And at first we didn't have an existing database, but now we have one. Then open a cursor to perform database operations. So I don't really know what a cursor is, but it looks like this is a necessary first step to do stuff with the database. And then we're going to execute some commands. So I know what the SQL command does. I know creating a table. And then I also know that I'm now inserting stuff. There's some things. I have this %s. That's a little different maybe than some things we're familiar with. But shouldn't be, actually that shouldn't be unfamiliar. Now we're running select query, and then here, so if I were just running this in the terminal, a select query, I would just get the result. But here looks like there's a whole bunch of extra steps that I'm gonna have to do. Looks like I have to call this method fetch1 in order to actually get the result. And then I have to commit. So I can run an insert statement, but maybe it doesn't actually save to the database until I run commit. and then I have to close or clean up. So I'm not quite sure what this does, but I do remember from dealing with files and CSVs that there's when you open a file, usually you have to close it too. So you explicitly open a file, you do some stuff with the file, and then you have to close it, right? So that pattern seems to hold here. So when we were working with CSVs and files, the first thing we did was this, let's say, more explicit style, where we are more imperative style, where we say open the file, do stuff with the file, then close the file. But we also have this handy context manager in Python. So using the with statement. So we can kind of handle some of this stuff. So we don't have to explicitly close the file or even handle errors. We will run something in the with statement so we can avoid having to do some of this extra stuff. So we'll take a look at that in a second. But I just want to show you kind of how you can think about these things, even though this is a brand new thing, and it's maybe seems a bit weird or doesn't match up. But there's a lot that's parallel. So you should be able to apply things that you already know about Python from other. So there are similar patterns or APIs that Python code will use. Okay, so let's take a look at some of this other stuff. So we have connect, we have cursor. So this tells us a little bit. The function connect creates a new database session and returns a new connection instance. So running this connect method. So this looks like con is going to be an instance of a database session. So we're creating an instance of a class, or an instance of a class. And then there's a whole bunch of methods built on this class, including, looks like cursor. So what is it? Create a new cursor instances. So you look like you can create classes from classes. So use the cursor method to execute database commands and queries. So looks like you can you create a cursor. So this is maybe like when you're manipulating files, you can use seek to move around in the file to different positions. And then execute. I think execute's pretty straightforward. Fetch one. We can take a look at the API, but fetch one. There's probably going to be maybe fetch all or fetch a bunch or fetch a given number, something like that. And we can see here we have fetch one, fetch many, fetch all. So things kind of should be coming into focus. Maybe even if the specific syntax doesn't make sense, just how this works. And we could explore the documentation further, but I think that's probably a good overview. All right, so now now that we've got the basics of what psycopg is and how it works, actually let's go ahead and try taking a look using the with statement. So this is a very imperative style. We're telling it every single thing to do every step of the way. So we can make this a little bit more declarative by using a context manager. So we'll start with, and then I'll copy this here. Actually, before we do that, there's another problem we're going to run into. So let's go ahead and have that problem right now. So we'll run test again, and duplicate table relation tests already exist. I think we've maybe seen this before. Did we see this? Yeah, relation tests already exist. So we have this error. We've already seen this error, but we didn't really solve it. We kind of worked our way around it a little bit. But now we have another error. So just think for a second about why this error is occurring. So if this were just normal SQL and we were trying to create a table and it's saying you've already got that table, the way we typically handle this in a script, especially when we're developing, is we'll add another statement that says conditionally, so if the table exists, delete it. So we can add that line very easily right here. So cur.execute. So if I want to execute a SQL command, we'll do drop table if exists. Oops. And the table name will be test. So let's try running that again. Okay, so it looks like we don't have any problems, which is nice. We can also try adding something. So this cur.fetch1, looking back here at this, looks like it returns what kind of data type would that be? If you guessed tuple or tuple, depending on how you pronounce it, then that is correct. So we should be able to just access it. So if we're in the, down in the guts in the in a REPL or something, this would be, we could just go ahead and check out the value. It would display immediately, but here, since we're running a script, we'll just call it. So we'll assign it to a variable name and then print it. Let's run that script again. All right, cool. So we get the results that we expected. All right, let's go back to transforming this into a context manager. So just like open, like with open, whatever. So we're going to use this here. So with this connection, and we'll do just like we would do with a file, like as CSV file or whatever. We'll do as con. We'll just keep with the naming conventions here, right? And then here, this may not be obvious, but this is also can be a context manager. So we'll have a nested context manager. So with con.cursor, as cur. Okay, so now we're here. And then everything else is basically the same. So let's go ahead and we'll copy all this and we'll just paste it right in here. Okay. So the question is, do we need to commit and close? So we could look at the documentation. So a context manager, part of the reason to use a context manager like the with statement is to abstract some of the more, standard procedural stuff. So if we have this imperative style where we're telling it specifically, open this file, do this thing, now commit this file, now close this connection, now close the cursor, now close the connection. So that's, maybe if this is all kind of standard stuff, we can abstract it away and get something that looks a little cleaner. That's more declarative. So let's take a look here at the documentation. Let me just do a search. Context with statement. So you can search through the documentation. I happen to know where it was, but if you didn't, that's fine. This is also in a couple other places too. We can see that starting from version 2.5, psycopg2's connections and cursors are context managers and can be used with a with statement. So here's an example. So again, if we wanted to construct this based on an example we get from this tutorial, this is a good place to look. And it tells us that, okay, so it looks like everything else works the same, but we get a nice warning here. Close still doesn't work. So it handles closing the cursor and the connection. It handles closing the cursor, but not the connection. So we're still going to have to explicitly close the connection. That's okay. And if we were doing this properly, we would want to include this in a finally block, just to make sure that if there were any errors that happened, that this connection would actually be closed. I'm going to skip that out of pure laziness, but we would just put a try and then a finally block here. So if there are any errors, we could do something, and otherwise, basically, we would always close the connection no matter what happens. So let's go ahead and run this and see what happens. Looks like everything works just the same. So we've gone from a let's say a slightly older style to a slightly newer style with a nicer API, even if it seems a bit weird at first. This is a little cleaner. Okay, so now that we have a good idea about how the basics of this, we can always look up if we have specific use cases and we need to do something, we can always look things up, but we have the basics of how this works, how this library works, or module works. All right. Okay, and so there's another example here in the README. Feel free to go ahead and try that out. Good practice. We're going to do the CSV example. So we've been working with CSVs, but we can also just, not only can we export things from a database to a CSV, if you wanted to do that, you can export the results of a query to a CSV and then import that into Excel, and that might be more useful for a client or a consumer or yourself. You can also do the reverse. You can read things in from a CSV to a database. So if you're converting something. And there are actually methods, if you look in the documentation for psycopg, there's a copy, copy to and copy from. But we'll kind of do it all by hand here. So the first thing we do is we're going to create a database called Sacramento Real Estate. Okay, so I'll have to drop it. Okay, so I already had one, so now I dropped it, and now I have recreated a fresh one. All right, so I'm still in my SQL virtual environment, so everything should work fine. I should be able to use psycopg still. Nothing has changed. So I will do, I'll call this housing.py, or, well, I should call it csv.py, but I already call it something else. So csv.py, csv example.py, I'll rename that. All right, csv example.py. Looks like we're going to import a CSV file that we don't have. We're going to be reading it. We will use the dict reader, and then we're going to use IPDB set trace. So we've imported psycopg2, which we have, no problem. We're also importing IPDB, which we do not have, so that will be a problem. Let's go ahead before we do that, and we skipped a step. We're supposed to grab the CSV. So if we go to that link, we can see the CSV. How do you actually get this thing? Well, you can go to raw, and it will give you the file, just plain file. You can copy all of it, and we'll paste it into a file. And I'm just going to simplify this and keep it in one directory. So I'll call it data.csv. Save that, and now I have a CSV file with all of the data. So I'm going to change the name of this to data. All right, so if I try to run this now, I get an error as I expected because I don't have IPDB. So what do we do about that? Well, we can install it. And because we're in our virtual environment, that's not going to pollute our global environment. So pip install IPDB. Okay, so it installed IPDB. That's great. Now, if I want to see everything that's in my local environment, I can do pip freeze. And it looks like I have a whole bunch of stuff. So I've only explicitly installed psycopg2 and IPDB, but IPDB has a bunch of dependencies. So it installs everything that it needs and so on. So everything that any of these modules needs should be here. It's kind of like the package lock.json file. It contains a full list of everything that's needed. And actually, virtual environments are good for a couple reasons. One is all the reasons that we've gone over from the previous video. Another reason is that it's very easy to communicate to someone else exactly what your project needs to run. So just like in Node, you have a package.json file, which tells you all of the dependencies and the versions. So right here, you can do something similar with Python, where you can take the output of this, so pip freeze, we'll redirect it, and I'll redirect it to a file called requirements.txt. This is the standard name. And now we have a requirements folder, so we can push this up to our project in GitHub, and then anyone who needs to use our project will just install all of the modules in the requirements.txt, and they can have the exact versions and everything, so you can be sure if it works on your computer, you can be pretty sure that it will work on someone else's computer. So that's just a side note. We don't need to worry about that right now, but another benefit of virtual environments. Okay, so now that we have everything needed, let's go ahead and run. Okay, so we've used this IPDB.setTrace. So as soon as we get here, we're going to stop. And we can take a look around in our code. So if I want to see what row is, I type that in. Okay, what about row? I want to see just the price. Okay, so you can play around with the debugger just to see what you're working with. It can be enlightening. All right. So as the README says here, CSVs are just, it's a plain text file. So everything is text. There's no data types, numbers, anything like that. It's all just strings. So what we're going to do here is, I'm just going to copy and paste this, but what we're doing here is we're going to clean the data we get from a CSV. And if you've ever worked with CSVs or done any like data science kind of stuff, you'll know that finding the right data and preparing it and cleaning it is like 90% of the work that you do. So we have the CSV. This could have come from anywhere, and maybe it was made to serve one purpose, and we want some slightly different. We want to, ask a question that maybe the original author didn't think of. So we might need to change some things around or modify some values or do whatever. So here's just one example of how you can do that. There's of course more complex things you can do as well, but we'll stick with this. Okay, a couple things. So we've got all this in here. I'm going to go ahead and exit here. Q. Okay, so we've got IPDB. We're importing decimal, date, time. So we have a couple methods, and then we have this connection object. And here, this is a little bit different. So on the tutorial, we saw we basically had to input our username. So we hard coded that, but here we can use Python as again, another very powerful and commonly used standard library that deals with operating system, so it can dynamically get that information for us. We don't have to hard code it. And we have already created this database, Sacramento Real Estate Database. So we're good there. We create this connection instance, right? It's an instance of the class. And then we can create a cursor, and then we can execute queries. So before, in the example that we saw, execute was, we just passed it a string. Here, we're developing a more sophisticated application, so we're not just going to pass it a string. We're going to, well, we are going to pass it a string, but we're going to create that string first. So table creation query looks like we're going to use this to create the table. So we've just saved that here. So, it's still a string, but it's a little bit more modular. It's out of the way. We're not polluting our namespace with global variables. And if we need to change this, we know where it is. Okay, so not that much different, but again, because table creation query returns a string, we can use that here. Then we're going to open. We're going to have to change this name to data. Okay, so it's the same thing we were doing before. So we just open this, the CSV file. We're going to use the dict reader, and then we're going to iterate over everything in the dict reader. So this is every row is going to be a bunch of dictionaries, as we saw when we were using the debugger. So for every dictionary that we get, which will represent a row, we're going to clean that row. So clean data. And it looks like we're going to create a new dictionary. And one question when we think about this, is this a pure function or an impure function? So let's think about what it takes as a parameter and what it returns. So it takes an object as a parameter, and you may know that objects are passed by reference. So it would certainly be possible to modify the original object, which could exist outside of this function. So we have potentially an impure function here, because this could be modified. But it looks like we're creating a new object here, and then we're building up a new object based on the values here, but occasionally we're taking the value as is, and occasionally we're converting it. So number of beds we're converting to an int. Again, keeping in mind that CSVs are all just boring old strings. And it looks like we're doing some more complicated conversion here, maybe some date-time conversions. Dates and times are always complicated and a huge pain, but you can take a look at some of this. And then decimal. So it looks like we're creating a new object and then adding a bunch of properties and then returning that new object. So it looks like our original object isn't being changed at all. So this is a pure function. It takes a parameter and returns something new, and it doesn't have any side effects. And if I give it the same value, it should return the same value every time. Okay, so I clean the data, i.e. I change some of the types. Instead of just being strings, it'll be a string or a date or a float or whatever. Then I'm going to execute the query. And this is a little complicated, but it's the same basic thing that we saw in the example, where we're just inserting. We have our column names and then the values. The value stand-ins, and then we're passing the actual values here. So here, again, this is maybe hard to read, and we could format this better if it were larger, but we're just inserting all of these things, and we're grabbing all of the information from our cleaned data. We're inserting it. Then we are committing and closing. So we're using a with statement to read. We could also use with statement to interact with the database, but this also works just fine. So let's go ahead and run this, and we'll see what happens. So it looks like it runs fine, but we can't really tell. So we can go ahead and let's go ahead and print out. We'll just go ahead and make a basic query. So a few things we could do in order to execute this, we could go inside of our interpreter. There's different ways to do that, but we'll just write a basic query here. So we'll save this so we can print it. Cursor dot execute. We'll just select everything. So select star from properties, and then we can't. Well, we actually can iterate over this. I believe we should be able to iterate over this, but we'll do it res dot for item in res dot fetch all. So this should give us an array, I believe, of every item that matches our. Oops, this is. And we'll print item. So let's run this. Let's see, relation properties already exists. Yeah, so we're gonna have to do the same thing we did before, where we'll add, let's see, where should we put that? We'll just put it right here. So drop table if it exists. And it is called, what is the table? Properties. All right, let's try running that again. None-type object has fetch all, cursor. Sorry, I have a little bit of a bug there, brain fart. So here, I actually did this wrong. So the execute is not on. So I'm executing here, but if I want to see the result, I don't just assign this here. So I execute the function, and then if I want to see the results, I do res equals cursor. Oops. Cursor dot fetch all. Let's look at the other example here. So, and then we'll print out the cursor. And we get everything, which is kind of a huge mess because it's just an array of objects or tuples. But so we could potentially do all kinds of stuff here. So we're selecting everything, but we can do specific queries. We can also create this database here. So let's keep this as it is. We'll run it again. Okay, and then if we wanted to create another query file, so down here we're asked to run some queries. So we could either do that directly in the shell. We could also create another file, and we'll just paste this in here. So we're gonna have to, we can't just run the queries. We're gonna have to set everything up just like we did here. So we're gonna have to import, we'll import these two things. So psycopg2 and OS, and then we'll have to create, let's create a database and then a cursor. We'll copy both of these. So So when we populate our database, that's kind of what we're doing here. We could also run queries here, but to separate our concerns a little bit. So we're populating the database, and then we close our connection. So now our database is closed. So if we want to run queries, we're going to have to create a new connection to the database, and then a new cursor object. Then we're going to have to execute our query, and then fetch all, and then we're going to want to close. So we're just doing this quickly, so we won't use the with statement, but we'll do cursor.close, and then we'll do close our connection. So connection.close. We can try running it, and that works just fine. So now we've kind of separated out creating the database from making queries. So I think that should be it as an introduction to psycopg2. It's pretty straightforwardly SQL queries just passed into these Python objects and functions. So after this is basically how it works. We're going to look at an example just so you can get an idea of how everything might be used. Because you might be thinking, what is the point of all this? It's just adding this extra layer of complication, and we could just run SQL queries directly. Why do all this?